I'm here today with Hans Kierstead, who is Professor of Anatomy and Neurobiology here at UC Irvine and a member of the Sue and Bill Gross Stem Cell Research Center. Welcome, Hans.
Thank you.
Let's talk a bit about spinal cord injury.
Spinal cord injury is a devastating disorder. Besides the loss of ability to move your legs, spinal cord injury results in the loss of bladder function, bowel function, sexual function. It's a tremendous blow to anyone in life.
There's another group that isn't really talked about, and that is our soldiers in combat. Do you think your work has kind of implications for that population as well?
One of the target populations of our research is individuals who have been injured in war zones. It's a very, very prevalent injury, either from blasts or gunshot wounds.
The studies that you had to do in the laboratory really speak to how effective that might be in humans.
Stem cells make humans. All that we are come from stem cells. So it makes a lot of sense, theoretically, that one could take a stem cell and make it into spinal cord tissue, and in fact, one particular spinal cord cell type. So that's what I sought out to do. I took the cell that can become any cell in the body and pushed it to become a particular spinal cord cell type that's lost after spinal cord injury. I'm really pleased to say that our treatment was recently approved for clinical testing by the FDA, and it ends up being the first human embryonic stem cell-based clinical trial in the world.
The work that you've done in your own lab has developed a method whereby you could take a cell and transplant it into someone suffering from a spinal cord injury. But there are other uses of stem cells, which is potentially using those cells to develop better, safer drugs.
So how is it that one comes to a heart drug that's safe? You have to have heart tissue to test it on. Human embryonic stem cells provide us with that bulk material that we can differentiate into heart and test drugs with. It takes approximately $1 billion to have a drug pass through clinical testing. That includes all of the ones that fail. It includes all of the costs of the one that worked. This underscores the necessity of working with industry. That money has to come from somewhere. It's about running an industry where we can generate cures as a society, where we can generate treatments that have a real viable chance of actually getting to people. I don't want to spend my life doing research in a university and making rats walk. I'd like to be out there helping people. In order to do that, we need the intelligence, the experience, and the money from industry.
Talk about the importance of private donations to support stem cell research.
I've developed 3 treatments that are either in the clinic or just about in the clinic, and every single one of them started with donor money. Support that allowed me to make a move quickly, to fund a student, to fund a technician.
How do you think people will look back at the importance of Proposition 71 in establishing this institute, the California Institute of Regenerative Medicine, the state funding agency that supports stem cell research?
The California Institute of Regenerative Medicine allocated a tremendous amount of money for stem cell research at a time when the federal government was virtually banning stem cell research by prohibiting the use of federal dollars. When this state was educated about the rights and wrongs of stem cells, what was real and what was not, they made the overwhelming decision to support it.
You've traveled all over this country, all over the world, talking about your work. What have people around the world seen about California?
The world leans on California as the base, as the very crux of the stem cell field internationally. The California Institute of Regenerative Medicine has resulted in an amazing amount of discovery and now clinical trials in an extraordinarily short period of time.
When you talk to patients and their families, what do they say to you?
The suffering behind closed doors is so tremendous. It's extraordinarily motivating to try to come up with something that's going to help these individuals. If you come up with one thing, it trickles through this neuroscience community and gives birth to other ideas. It's a beautiful reality of scientific research.
Well, it's been great talking to you, Hans, and thank you for all your work on behalf of the Stem Cell Center and UC Irvine.
Thank you, Peter.